Welcome back, students, to another video. This video is going to focus on practice set 3. And firstly, let me say in the practice set 3, it says practice set 3 like in practice set 2, but this is indeed practice set 3. So if you're looking at something like this right here, that is practice set 3, and we are good to go. Now, because this practice set 3 focuses more on group bys and more complex problems within, not more complex problems, but more of like selecting subtables within a larger table. In this case, this table I show you right here. This is basically, consider this a table that's like 100 rows or 1,000 rows or whatever, 10,000 rows, doesn't matter. In this case, it's going to be 100 rows. But the first 7 rows are these row values right here. This is so you just get a feel for what the table is, and you can answer some more of the questions that deal with the first 7 rows. But as the questions go on, we're going to be doing group bys and some other things. And you might want actual practice, which I strongly recommend. So I also created this, let me zoom in. I created this Python file right here. It's called pp3_table.py. And if you run this code will basically create the table df that you're looking at right now. In the PDF right here, you just simply see the first 7 rows. Right, and as you see, the numbers should align up perfectly. The values you see in each one of the columns, and the values you see in the table, the first 7 rows. But I give you like fake data on more fake 93 other additional rows, so you can play with this. You can work through it, and see if you get the same results as I do. And it's just another way to have a lot of practice. So I will have this code up there for you to run also, so you can do this side by side if you'd like. All right, so let's go ahead and jump on this. The first question will be number 1, right? And number 1 is basically asking, what will you get back if you run the command df.iloc2? Now, iloc does what? Iloc works basically the positions of the table, right? The position of the values. The position of the value is not necessarily the index. So df.iloc2 is basically going to be the 0th row, the 1th row, the 2 row, right? Notice we just have one value here, so we're just going to go ahead and grab grapes, this whole row right here. So basically the answer is going to be literally this whole row right here, right? And it just so happens that the positions coincide with our indexes. If our indexes were different, right, then you would see a discrepancy. But here they just happen to coincide with the position numbers coincide with the indexes themselves. So I'm trying to copy, let me just type this in. So basically you're going to get back something like this row, grapes, 5, and you can show it like this if you want in the exam, 180 Feb dash 5 dash 2017. If you run this in pandas, you'll see the output slightly different, but that's okay, right? That's okay. For example, let me just do hashtag, separate this out. Right, if I were to do df.iloc2, you would see the value comes back like this. It comes back as a series going down, and that is because if you remember from the previous video on lab 1, when you select one row of a pandas table, just one row of a pandas table, the result comes back to you obviously as a series, but it comes back as a series where the column names are indexes going down and the values are the values going down. And it does this because it's just easier to eyeball it. Like if you had a massive row up table with massive amount of columns, it's easier to see the relationship between the values and the columns if you go downward like this, right? So you can give me the answer either or, it's fine. I get the gist of what you're getting to. I just need to see pretty much you got the right gist here. All right, so that's number 1. Number 2, what will you get back for df3? Oh, here I have a typo, guys. I have df3 here. This should be df3. This should just be df, not df3. So here, number 2, we have a typo. Let me just write down here. Typo should be df, not df3, right? So number 2, what will we get back? So here, guys, I'm using the loc function. And remember, the loc function looks at the index. It looks at the index. The index here is going to be 3. And it's basically selecting this row. And then comma, it's selecting it's doing, after to the right of the comma, it's doing a bracket, comma, bracket slicing. Why is it doing that? Because it's selecting not one, but more than one column. In this case, two columns. So if it's picking the third row and the fruit and price column, basically the answer that's going to come back is basically plums, right there, plums dash 2. All right. And obviously you can see it'll come out, the output might be slightly different. I mean, the values will be the same, but the way it comes out might be slightly different in pandas. Number 3, change all the prices of orange to 4. Excellent. Change all the prices of orange to 4. All right. Let's work this out. Change all the prices. This is number 1. And now we're jumping to number 3. Okay. Now, if you remember, right, this is now going to be not a colon selection. This is not going to be a comma bracket selection. This is going to be a logic selection. So basically, again, I'm going to have df dot, and remember we do a logic selection, you could do, right, you can use the brackets, but we're asking to now update all the prices of orange to 4, okay? Some of you guys might do this. Let me do this actually outside of this first. Right? Recall again, let me do a little review, that if you do df orange, what's the name of the orange column, the fruit column? Fruit, excellent. Fruit equals, remember, single equals, you're creating a data container, bookshelf, or transforming an existing data container, bookshelf, right? Double equals, it's a logical check. It's saying, hey, is this value equivalent to this value? Double equal means equivalent. So where in the fruit column is the value equal to the value orange? Excellent. And you get all these bunch of true and falses, if you guys can see in your window, right, if you were to do that. You remember how these true and falses work? If you place these true and falses back in here, if you place true and falses within the table itself, right, like this, then this, if I run this, is literally going to give you, this then creates what we call logical slicing or Boolean slicing. That's what true falses are. They mean they're true, they're a type of variable called Boolean, something special in programming, right? They can either be true or false. So what happens is all the trues from here, right, within the brackets, within the square brackets of the data container itself, like we see here, like see, this now is just the bracket, and then we put this same logic from line 34 in here, close the bracket. It's going to grab all the rows where the value is true, right? Grab all the rows where the value is true. Right, excellent. And that's why in your window, you will now see all the rows within the table where the fruit is orange. The value of the fruit column is orange. Now, what some of you will do is you'll be like, all right, cool. Now let me change the price, like we said here, to 4. And you're going to do this, right? Let me select this now. Now what do we do? All right, excellent. So now we chose all the values that are orange and just the price columns. This or on the side of it is that those are the index values, of those particular rows. So now we want to change these values to 4, and then you'll do something like this. And you will get an error. Okay? Why will you get an error? Let me put error here. Error. Why do you get this error, guys? You get this error because you cannot update a table when you are just selecting some of the values in that pandas table. Pandas does not allow this. All right, Pandas does not allow this. Yes, you can change. Yeah, let me mess with this for a second. You can change hypothetically, if you wanted to, you can change all the values of the, let's say, price column to 4. There you don't get an error. Why? Because you're updating the whole column. I'm going to go up here and rerun my line 25 just so I get my original table back. Sweet. Because here, you're running the whole table. I mean, you're changing the whole, every value in that column. All right? That will be allowed. What will not be allowed is picking and choosing which rows in a particular column you want to change, which is what's happening in line 35. In line 35, we are saying, hey, no, we want to change the values in price, right, in the price column, but only for the rows where its fruit column is saying it's orange, right? No, 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 can't do that. How do we do it? You guys remember from lab 1 how we do it? The lock function. That's how we do it, the lock function. So I got my df.lock, let me do it here. Pop that in, boom, comma. To the left, I select the rows. To the right, I select the columns. Which columns do I want to change? I want to change the fruit column. I'm sorry, not the fruit column, the price column. And I want to make that sucker 4, right? How do I select which columns, which rows I'm going to select? I'm using the logic from 34. I'm taking the column of true and falses that will be created from this logical check. I will place it here in the LOC, and as I said before, everywhere where this is true, LOC will grab the index, but only for the rows, only for the values where it's true, and it'll disregard the falses. Now, I run this, there is no error. You notice that? There is no error. And now we can double check this by simply selecting all the values. Right here, I'm just going to select all the values where fruit is orange and just say I want to actually, let's get rid of the column. We want to see let's see the whole, let's see all the columns, not just the price column. And I'm going to select this, and now you're going to see a subset of the data again. You're going to see all the columns come back for just the rows where fruit is orange, and now you'll notice the price is orange. That is the correct way to do this, and this is why this is the answer. Copy and paste this, put this right in here, and that is why that is the answer, guys. Right? Number 4. Change all the prices of orange to 5 where sales is less than 100. Ah, okay. All right. Change all the prices of orange to 5 where the sales is less than 100. You see what's happening here? Before, in number 3, we had one logical check. Now, in number 4, we got 2 logical checks. Basically, as in Excel, like you know how you have an Excel table, right? And you filter one column. That's what we did number 3. We filtered all the rows of a table in Excel by one column. We basically clicked on the fruit column and said, we want to filter you, the fruit column, just for the values orange. We checkbox the orange, boom, you got all the, you got only the rows where the fruit value is orange. Now, I now have 2 columns I need to filter in Excel. I am going to click on the fruit column. I'm going to say, hey, wherever the values are orange. And now, but I also need to go wherever there is the sales column is, to say, hey, wherever the values are less than 100. Show me the rows that meet both these conditions, okay? Show me the rows that meet both these conditions. We never explicitly talked about this, but the logic to do this will be the and %, right? You will need the and % because you have 2 logics here, 2 filters. And both filters need to be true. Both conditions need to be true. Therefore, you're going to separate them by the logic and, right? The logic and. Let me show you this. All right, so here, again, everything's orange, right? It gives you true, falses, etc., etc. Boom, boom, boom. The other logic we have is sales is less than 100. So right below it, I'll say sales less than 100. And that's an integer, so I don't need quotes. I mean, that's a number, so I don't need quotes. Boom. And now here, line 43, you're going to see a separate column of false and trues. We need both these conditions. How are we going to do it? All right, so obviously you guys know we're going to use the LOC. Right? Obviously you know we're going to use the LOC. I'll take the answer from 38 and I'll modify it. Right? Firstly, I want the price to equal 5. The first condition is already there from line 42. Boom. The second condition, right, because both conditions have to be true, There's one of two ways you can join these conditions. One is the ampersand, which means and. And the second way you can join these conditions is the pipe. This pipe it usually shares the same keys as the backslash, and it's a button that's very shiny and new on your computer because you hardly use that button. Congratulations, you're finally using that button. All right, and this means or. For my ABI students again, you guys, this should be a refresher for you guys did this in the R using data tables. All right, so here I'm going to write this, and it's going to be a mistake. All right, so the first time I write this, you're going to error, and I'm doing this because I'm going to show you some interesting concept in pandas here. So the first way I write this is going to be wrong. So I have the and there, and now I'm going to put the condition from line 43. Boom. And now I have both conditions in here that must be true. So this must be filtered, and this filter must happen. And then whatever rows are left, make those values price equal to 5. All right? Now when I do this, actually what we should do is let's see if there's any value. Let's see if there's any rows that actually meet this criteria. So when I do this, right, I get an error. Like I told you guys, I get an error. Why am I getting this error? I'm getting this error because once you have more than one condition and you start using these ampersands to separate the conditions or join the conditions, or these pipes to join the conditions, each logical declaration, by logical declaration I mean whatever's in line 42 and line 43, that's what I mean by logical declaration. Each one of these must be wrapped in their own individual parentheses. That's what the error is happening. So here, this condition, check, must be in its own parentheses. And this condition, check, must be in its own parentheses, right? And now when I run line 44, guys, you'll see you get the right answer. It just so happens I don't get an error, but I don't get any output. It just so happened, unfortunately, that I don't have any situation where I have an orange, I have a fruit that's orange, and I have sales that are less than 100. Apparently, they're all greater than 100. That's my bad. But anyway, the way this would, hypothetically, it doesn't matter. Let's say we did have a row or rows. This is the right way to answer it. And if I did this, notice again, there's no error, but we know no row is being updated because no row actually meets both those conditions, where the fruit is orange and the sales is less than 100. Right? But nevertheless, this is how we would answer that problem. So this is the answer for 4. Alrighty? Number 5. Create a new table DF2 with just the sales column and the price column. Okay, so this is easy. There's several ways you could do this. Right? We can do DF2 equals DF double bracket, and I'm going to choose sales. What is it? We say sales column and price column. Sales, price. Right. So this is real easy. Or you could, if you want, you could use DF2. You could use the LOC command. For the LOC command, remember you have to specify which rows you want. So this is a little trick I want to show you. If you put colon in there, if you guys remember this from I believe our intro video, colon here to the left of comma I put the colon. What that means is, who remembers? All the rows. It means everything. So I'm basically saying give me all the rows, but just the, and that this part will be the same as line 14. Just the sales and price column. All right. That's number 5, a little more straightforward. Number 6. Excellent. Create a period column in table DF that converts the string dates from date string into a date object. Who remembers the function we used to do this? That's right. pd.to_datetime. pd.to_datetime. This is basically, I think, number 2, I think, in our lab, right? In lab 1, I think. So it's going to be a new column called period. And because it's going to be for every row in the column, again, remember, I don't have to use loc. I can do df period equals pd dot 2 underscore, oops, and I give the column that has that value. Oops. And that will be df date. Scroll up here, date. And that's how you will have, and you guys can go back into the code and try that, to that additional code, and try to see if it works the way it should. Number 7 here, create a table df2 where all the sales are greater than, okay. Let me scroll this over a little bit. So now you're going to create a table df2 just like we did in number 5, except we're getting a little more, we're filtering it by value. So here we want to create a table df2 where all the sales are greater than 100 and the price are greater than 5. I think price is greater than 5, whatever, little typo there, but whatever. The sales are greater than 100 and the price column is greater than 5. We have 2 conditions, guys. We have 2 conditions again. You remember that? We have 2 conditions. All right, so how am I going to do this? Here, it's probably safer to use the LOC. I believe both ways will work, but I would probably use the LOC function. It's probably a little safer here. So now I want all the columns, so that's fine. I don't need a comma in this case because I'm not going to use the column section at all. I just want to use the filter. So here I'll simply say df2 is going to be df.loc parenthesis, close the parenthesis, and I'll put my first condition in there. What's my first condition, guys? df sales greater than 100. Done. And df price greater than 5. Close the bracket. Again, I don't need the comma because I'm not using, I'm not sub-selecting the columns. I'm taking all of them. And so I'm done here. All right, so I'm done here. All right, so that's pretty straightforward at this point. Number 8. Create a table df2 that has the 20 lowest prices for only fruits with sales less than 250. Okay. So here we can do this in one step. We could do this multiple steps. I'm going to go ahead and do this in multiple steps, guys, because I feel as beginners, it's just easier to see it in multiple steps, right? But if you want to do it in one step, that's fine. You can do it in all the code in one line. That's fine. I had a student one semester that he would do everything. I don't care what I asked, how complicated it was. He would put everything on one line, no matter how long that line was. It made sense to him. It made sense to him. Amen. All right. So number 8, create a table df2 that has the 20 lowest prices for only fruits with sales less than 250. Now, there's a couple ways to do this, right? I can sort it and then take sales less than 250, or I can take sales less than 250 and then I can sort it, right? If I want to take multiple steps. So either or is fine. So what I'm going to do is I'm going to first filter it for sales less than 250. So I'm going to create a temporary table. I'll call that dft. So dft will be df.loc, and it's because it's just one condition, sales less than 250. So I'll literally do df sales. It's one condition, so I don't need parentheses, guys, but I think if you do put parentheses, it's not going to be a problem. df sales less than 250. All right, DF sales less than 250. Done. So now I have a table called DFT that has sales of 250. Let's see this, by the way, in action. All right, this is what, number 8? Let's see this in action, shall we? I can actually just copy this. Boom. All right, excellent. So if I run this, right, DFT, let me click on DFT here, guys. You'll see now that you only have the rows where sales is less than 250. So you created a table called DFT that only has all the rows where sales is less than 250. Done. All right. From here now, guys, I want to get for number 8, I want to get the 20 lowest prices. I want to create a table called DF2. I want to create a DF2 table that only has the 20 lowest prices. Now to do this, there's several different ways to do this. I need to sort it, right? So I'm going to sort DFT. So if I do DFT, how do we sort, guys? How do we sort a table versus a series? First, we have to put in which column we want to sort. So we want to sort prices. Price. I think the column name is price. And do we want ascending or descending order? Lowest prices, so 20 lowest prices. Okay, so if we want the 20 lowest prices, the default ranking of sort values is ascending. So we don't have to do anything with the ascending because by default it'll be it'll be ordered in ascending order. So on the top will be my top 20 rows. I mean my top my 20 smallest prices. Now, if you want to permanently change the order of the DFT, right, you have to put in the parameter in place equals true. Okay, and now when I do this, we get some sort of output, but there's no error. You just get a warning. You get a warning of some sort. All right, so now if I do click on DFT, right, you will now see, look at the prices, guys. Right, now it's in order of the prices in ascending order. Fantastic. I just need to grab the first 20 now. So how am I going to grab the first 20? What will I do? And I'll put that in df2. So df2 now is going to equal what? How do I do it? Who remembers the function? Head. All right, and now I have a table called df2. And now you'll notice it's just 20 rows of all the rows where sales is less than, what is it, 250, where with the top 20 smallest prices. Top 20 slowest prices. Right, so I'll just go ahead and take this. And these 3, and again, there is, I mean, once we do more, like we add more steps like this, there are multiple ways to do this, guys. There's multiple ways to do this, right? So please don't think that this is the only way to do it. There's multiple ways to do it, right? So this is just one possible answer, right, that I wanted to give you guys. And again, you could do this all in one line. I took 3 steps to do it because I feel as a beginner, I mean, I'm not a beginner, and I like taking multiple steps like this. If memory is not an issue and processing power is not an issue, I like keeping things as simple as possible. Number 9, create a bar graph. Okay, we'll skip number 9 because this is the graphing thing, and I wanted to skip that. Remember, we'll get to graphing. Don't worry about that, guys. I'll show you guys matplotlib. So don't worry about that. All right, number 10. There is a dictionary named payment type that has keys as the sales numbers and the value as the type of payment when the fruit is purchased. Add a new column in DF called ptype that inserts the correct payment for each sale. Here, guys, I basically want you guys to use the mapping function again to map the values from a dictionary throughout the whole massive table. So this was a part of our number 1 in lab 1. So here I'm creating a new column called payment ptype. And the keys in the table for that dictionary payment type is going to be from, oh, I'm using the sales number. The example doesn't make too much sense, but the idea is basically you want to take the values from this dictionary, put in this new value column, and sales in the table is the key to get those values, right? So in this case, df sales, and I'm going to map these values as keys to the dictionary that is payment type. Done. And that'll solve that problem. Number 11. Ah, yes. Now I'm asking you, what is the average price of all the fruits in the table? What is the average price of all the fruits in the table? How am I going to get the summary information? Group by, right? So if I wanted the average price of all the fruits oh, actually, no. Here, I just want the average price of all the fruits in the table. I don't even need to use group by. Just go right here. That's number, what, 11? I'm simply just calling a function on one column. So if I do fruits in the table, that's what the average of the price. It's called the mean function like this. And ladies and gentlemen, you get the output. That is 5.45, right? Obviously, I just want the code. I want the code, guys. I don't want the actual numeric answer. I want the actual code. So that's how we would answer that. And if you wanted the max of the price, if you wanted the sum of the price, the min, etc., all your aggregate functions, that's how you would apply it, right? That's how you could apply it. Number 12. What is the total count of each fruit in the table in descending order? Okay, here we go. What is the total count of each fruit in the table in descending order? Remember, I can get this one of two ways. We did this two different ways. But here I say I want it in descending order. So the easiest way is if I go here, this is number 12, and I do what? I do df, oh, fruit. We want fruit, right? All right. You guys remember what it was? Dot value count. Sorry, value count. And here you guys get the answer you're looking for. You get apple, peaches, pineapple, grapes in descending order. So basically, we have 19 instances of apples in the fruit column, 17 peaches, 16 pineapples, 15 plums, 11 grapes, 11 watermelons, 11 oranges. All right, nice and easy. So you can do the answer like this, and you can also use GroupBy to do it. So here, you can do it like this, or you can use GroupBy. And to GroupBy, remember, we're going to use the count function. So here, I will do df, what do I want to create a group by? Which column do I want to create groups by? The fruit column. And to the fruit column, so this is going to create a subtable for each particular fruit. There's going to be an apple subtable, a peaches subtable, a pineapple subtable, etc., etc., etc. All right. So within those subtables, which column do I want to select to count? Who remembers this? Oh, let me see if they actually made a change here. See if we can apply this directly to, I don't think we can. I don't think this will work. Oh, it worked. Excellent, excellent. But in this case, we wanted to, all right, so, I mean, this kind of works. So if you just apply it to the table as whole, it's going to go ahead and give you the count for each column. We just want one particular column because we want it in descending order, right? We want the results in descending order. So I'm going to go ahead and choose a specific column here to do the count on, and we could choose any one we want. We could go ahead and choose price if you want. What you can't do is you can't choose the fruit column. Because you're doing a group by the fruit, you can't choose that column to be highlighted, right? It's like, it's serving like an index at that point. So that's why you only see price, sales, and date over there. So I'll just take the price one, that's fine. And do count, and then you get this value. I'm gonna save this. Remember, these values, when you use group by, they come back as a series, right? Because we're getting this value back, but remember I said I want it in descending order. All right, so I'm gonna save this as a temporary thingy. This DFT now is going to be a series, not a pandas table. So if I want to sort this, I can do sort underscore values, right? Problem is, it's a series, meaning there is no column names, meaning you can't put a column name in there. You'll get an error. So we just do sort values, and it'll automatically sort by the values. Now, the question is, would you want it in ascending or descending order? We want descending order. So we have to put in ascending equals false, right? And also we can say, listen, make the change permanent. So do in place equals true, not TR, but true. I'll run this, and now DFT, ladies and gentlemen, will give me the exact same results as value counts. All right, and so these are the two different ways. These are two different ways to do it, guys. Number 13. Number 13, what is the total amount of sales amount? So it looks like I'm summing up, I want to sum up the amount of sales by fruit in ascending order, just top 5. Okay, so I'm getting a little fancy here, guys. I'm asking you a bunch of stuff. Just trying to test you guys here, see if you can handle this. All right, so I want the total amount of sales by fruit. Done. I want it in ascending order, and I just want the top 5. All right, so first things first, again, I'll take multiple steps. I want to first sum up all the sales by each fruit. Okay, not a problem. We're doing our group by again. I'll do this here again so you guys can visually see it. So we're doing df, creating my group by what? Group by fruit. Oh, let me save this. dft equals df.groupby. I want in each subtable, I want to highlight the sales column, and I want to take the sum of the values, right? I go ahead and I run this, and I do dft, which is going to be a series, and I have my fruits all summed up, their sales all summed up by each fruit, okay? Now, I want the results in ascending order, but I just want the top 5. Okay, no problem. So if I want it in ascending order, I'm just going to go ahead and do a little sort action here. Right, sort. This is a series right now, so ascending order, that's fine. It's going to be by default in ascending order. So I just want to make the change permanent. All right, let me type in DFT here, and now you see the result in ascending order. And I just want the top 5 values because this is a series. Let's see if we can apply head to a series, and you can, and we are done. So this, ladies and gentlemen, is one way to do it. All right, I will show you another way in a second. So this is, obviously the one way to do it, right? But we can also do it if I made it into a table, right? I'm going to show you another way. I'm going to show you, basically the same way, just an extra step. Let's say hypothetically we ran DFT, we got the series, right? But now let's say I wanted to actually work with a pandas table. If I did, remember, dft.reset equals dft.reset index. Remember this, guys? What does this do? This will convert that series above into a pandas table with indexes and the fruit and sales column. Remember, the index that was the fruit was pushed into tomato column, and the initial values is now converted into, is given the name sales. Now this is a pandas table, all right? Now this is actually not a series, this is a pandas table. If I want to sort this now, I'm going to sort it like a pandas table. So it's basically going to be, the only change is I have to specify a column that I want to sort by. I want to sort by sales, because remember, I want this in ascending order. So I choose to sort by sales. Everything else is the same again. Type in DFT, you see that? Cool. And then I could do head 5 again. So some of you guys might be like, why would I take the extra step? I like, personally, working with pandas tables over series, even though I do both. right? So I just wanted to show you guys there the nuance, the slight nuance difference, and to reiterate to you guys the difference between a series and a pandas, and to reinforce the fact that, hey, when you use a group by, your results come back as a series. All right, so there you go. That is number 13. Number 14, what is the average price of fruit for each fruit? It says 4 fruits, but for each fruit where the sales is less than 200, less than 200. Ah, excellent. Excellent. So again, you could do this in one line. I'll do multiple steps to do this, but here we want the average price of each fruit for every fruit that has sales less than 200. In this case, I need to filter first because I want to do the group by fruits and I want to take the average price of each fruit, right? I want to take the average price of each fruit, but only in the situations where the sales is less than 200. So I need to basically say, hey, I'll show you that here again. All right, so it's basically going to be DFT equals DF. I can use LLC. I could use. I don't have to use LLC. It's all right because I'm not changing anything. Oh, let me use a different syntax here just to reinforce it. I don't want you guys to forget this either. I don't have. Instead of doing DF bracket colon sales plus 200, right? I can also do when you're selecting just one column. Some people find this easier. I definitely find it easier because it's less typing. I'll ease you guys into it. So line 76 and 75 are the same. You can write one column using the bracket quotes bracket, or you can do df.sales. I don't have to tell you what's easier, right? So I'm slowly easing you guys into that when you see me do that. So this will be sales less than 200. Excellent. I process DFT, and now you see all the rows where sales are less than 200. Sweet. Now I'm going to go ahead and do my group by, right? And I just want the average price of each fruit to have sales is 200. So I don't need to put this into a temporary table. I can just simply do TF to group by. All right. So again, what is the average price of fruit for each fruit? So what's my group by going to be done by? The fruit. All right. And what do I want to take the average price of? Sales. No. Oh, price. Sorry, price. And I just want the mean. I want the average, right? I want the average. And you see those results. You get the nice average, and this is pretty much your answer. I'm gonna just pick line 76 and 77 to show you, to bring it there. But I mean, in here you have both, so you can see them. Remember, 75 and 76 are exactly the same thing. I'm just writing them differently. That's it. And that's line number 14. And then finally, we are down to number 15. I believe that is our last question. First practice set. Yes, I'm right. So number 15, guys. What is the average price of fruit for fruits that have sales greater than, let me scroll over. All right. What is the average price of fruit for each particular fruit? That's what I showed. What is the average price of each fruit for each particular fruit that have sales greater than 100 and less than 350 in ascending order? All right. So it's basically like number 14, except I have an additional condition in there, and I throw in, hey, I want the final result to be in ascending order. All right. So no problem. No problem. So here, I'll take this. I'm going to add an additional condition. Sales greater than 100. And I have two conditions, guys. That means I have to wrap each condition each logical filter in its own parenthesis and join them with the and, because both have to be true. And df.sales and less than 350. All right. This, ladies and gentlemen, will give me a subtable of just which sales are greater than 100 and less than 350. All right. From this, I can go ahead and get the average price for each particular fruit using my GroupBy. That's literally this again. But I'm going to save this because I need to do some ordering stuff. All right, so now the results are going to be DF2. DF2 is going to be a series, right? And I want it in ascending order. No problem. If I want it in ascending order, I'm basically going to just sort it and not do anything to the key parameter ascending, because by default that's ascending order. So I'll just do df2 dot sort values in place equals true, and I'm done. And df2 will be my final result. All right, I leave that to you guys to check out in the Python code. We are now done with the practice set, so you guys have your solutions right here. If you have any questions, we'll talk about it in the Q&A. And I will post both the solutions and the Python code that creates the table for you guys to play around with, and whatever the few questions I did in here. By all means, please do all the questions in here if you'd like, just to see what the results are. Have some fun with it. All right, so this marks the end of our video, guys. I'll see you guys in the next video or in the next Q&A session. All right, have a good day, guys. Bye-bye.